Hi everyone, welcome to this presentation on Automation Studio. This morning we will go over the quick overview on hydraulic, electro-hydraulic, pneumatic, electro-pneumatic for Automation Studio. We will also start the part one of our multi-technology project. So we will build like a complete circuit that you see here, pneumatic with motor, PLC, and we're going to be using mainly the illustrated components, which are new elements that we've added into Automation Studio. So first of all, if you can please raise your hand on your dashboard if you can hear me and see my screen, just as a confirmation. If you can't hear me, okay, thank you very much. Perfect. So I've received the confirmation. So again, this is part one. So we're going to have a part two in next week, and then the part three in the week after to review the entire multi-technology project and insert faults also on the fourth webinar, which will also manage permission, how to block access to students to being able to modify a circuit that you've done, and also modify the access so they cannot see the properties inside each component. For troubleshooting purpose, it's important that they can actually just use a simulation and the measuring instrument. So we're a bit, there's too many people this morning to enable questions by giving you the microphone. So what we'll do is we'll have one of my colleagues is also connected, George Fatal, and we'll also being able to answer questions. So if you use your the question tab in the GoToMeeting, we will be able to answer you there. Or at the end of the session this morning, which lasts for 1 hour, we'll be open for questions, and then I will be able to give you the mic, and we'll go over them. And there's no basically limits on the question. We want to make sure that every question is answered following the presentation. Okay, so let's go into Automation Studio. This is the actual software Automation Studio. I'm presenting today version 7.1. It's a version that will be released. We're talking days, okay? So it should be out, let's say, within a week or so. And for the current users, you'll see here by the home tab, we've added the page format selection directly from the schematic here, and also the scale, which can be accessed directly from here, okay? So every time we add new features like that, it's always based on feedback that we've received from customers, okay? So the software Automation Studio combines multiple technology. We have hydraulic, pneumatic, drive-in transmission, electrical control for relay logic circuits, digital electronics, logic gates. We have ladder logic for Allen Bradley. We have the 500 and 5000 functions. We have so for Siemens, IEC, Mitsubishi. We have also electrotechnical for AC, DC motor control circuits, renewable energy, residential electricity. We'll see those in the second next week video. We have the one-line diagram for power grid layouts and mathematical blocks. So today we'll focus more on hydraulic and pneumatic. So basically the way the application works, it's quite simple. Okay, we select the category of our choice, and we can simply drag and drop our components on the page here. This is your 8.5 by 11 page, okay? So you know where the space you're gonna take when you print it out. So now let's just move it a bit and actually take components like this. Let me take one with the shaft here. So I take a pump like that. I can put a reservoir. I want to take a motor here, so I'm going to go into the drive-in transmission and just take an engine like that. If I would wanted to control the motor with another type of circuit, like an electrical circuit, I would have to use the electrical motor. But this one just automatically starts, okay? Then I'm going to go back to hydraulic. I'm going to take a pressure relief. Double act. Let me just put the 4-2 directional valve and a double acting cylinder. So once the components are placed on your sheet, you can directly go on the connection port and put the hoses between components. I say hoses because you can actually specify the length and diameter of your hose to simulate pressure loss. Okay, so let's just connect that here. Connect this to the pump, to the reservoir. The pressure relief will connect right here in the middle. You see automatically insert connections like that. I'm going to bring this one back down. And I want to use another tank. So it's Windows based. I can hit the control key on my keyboard and simply copy the tank like that. So once I've made this circuit without doing nothing else, you can directly go into the simulation tab and start simulation. So we can see the circuit in simulation, flow going from the reservoir through the pump, exiting my pressure relief, which is open. And if I click on the joystick here of the valve, the lever, the cylinder extend. And if I let go, it retract because the spring pushing it back. So it's very easy for students to actually follow what's going on in the system, in the hoses, which on the trainer, sometimes it's black hose, so you can't see inside. And that really enhance the understanding and also helps students transition from the theory to practice, okay? So every component that you use in Automation Studio, if you right click on it, there's a context help that explains about this particular component. You can cut and paste, you can print that out also. And a good feature also is that you can select part of your circuit like this. You can do copy. I can open Word, for example, and I can straight paste it like that into the document. And as you can see, the quality is very good. It's all vector graphic. So for you to prepare assignment for the students or for students to do reports, they can actually cut and paste their work into Word like that and then submit it to you. For example, if I'm an instructor, I can actually just select all the symbols on my drawing like this, cut and paste into Word, and as an assignment, I can tell my students to do the wiring diagram on that circuit. Okay, so cut and paste could be interesting. The software, as you can see, is very easy to use, very quick, but you can also change properties on component and see the effect on the system. For example, let's say if I take a second cylinder like this, I copy it here. I'm going to connect it in parallel with the other one. And let's say I want this cylinder to actually push a weight. So I can simply double click on this cylinder. And I'm going to access here the data, which is the properties of that cylinder. So you can see here we can change the piston diameter, rod diameter, the stroke length, the inclination on it, even the weight also if you want. We can put also push force, pull force, that can vary also depending on the position of the cylinder. But just keep it simple now, and we're going to put like a 40-degree angle and a 5,000 pound on it. If you check this box, you want to display this value on your schematic. So when I close here, I have the 5,000 pound. I can place it wherever I want. I can go to the Edit tab and actually change the font, change the color if I want. And once it's placed, it remains at that location. Okay. We've put 40-degree angle in the specification, but we left it flat like that on the schematic because we follow all the ISO standards and we don't turn components on schematics. But for teaching purpose, I can go here, position, rotation, change the rotation point, and actually rotate the cylinder like that. But the purpose of doing that is to also monitor the pressure in the system, what's going to happen. So I'm going to actually drag and drop a pressure gauge over here and a flow meter right at the outlet of the pump. So if I start simulation again, I can see I have 1160 PSI. If I click on my pressure relief, I can adjust the pressure live in simulation. I currently have about 13 GPM in the circuit. If I click on the motor, I can reduce the speed, which will affect the flow. Or I can actually click on the pump and edit the displacement of the pump, which will affect the flow as well. So now if I simulate again, let me just increase the flow a bit so it goes a bit faster. The first cylinder extends at about 20 psi, but the second one requires about 286 psi to extend. And then when it retracts, this one gets pushed by the weight coming in first, and then the other one comes in. So every small changes you'll do in the software will be actually visible in simulation. What you can also do is you can bring a plotter like that, and the plotter will actually trace curve of the simulation. Okay, so all I can do is actually place it wherever I want. I can take the cylinder, drag it on the plotter. I want to see the linear position. Same thing with the other one, the linear position. And let's drag the pressure to compare that to the pressure in the system. Now if I simulate again, I can actually analyze what's going on in the system in simulation. So this makes it very easy for students to understand what's happening. And once you've done the simulation, you can expand this window. You can bring in a ruler like that. And wherever you position the ruler, you're going to have a precise reading at that location. And if you want to push it a bit further, you can also export these value to Excel, for example, to analyze the simulation, or simply cut and paste into Word directly like we did before with the circuit. And we can have the legend here that you can show or hide some lines also. We can insert annotation, so we can document this plotter afterwards to when we make the copy in Word, for example. So this is for the plotter. We can also directly on the schematic insert a bill of material. A lot of the time students may not know exactly what the component names are, so you can display something like this, which will automatically update as you make modification to your schematic. For example, if I take a gas-loaded accumulator, you see it automatically added to the list, and if I erase it, it goes away. So you can actually create a template for your school where you're going to have a bill of material already made, and as you draw your schematic, automatically this BOM gets generated. Okay, and when it prints it out, it looks professional because you can have your BOM, you can have your title block at the bottom with your school logo, the student name, what's the file, when it was saved, and things like that. Okay. So now we've done the BOM, we've done the hydraulic circuit like that. What I'm going to do, something interesting also is that, especially this time with the online or hybrid teaching, we also can record videos of what we're doing on the screen and with voiceover as well. So if you want to record the entire application while you're explaining to students how to create a scenario, what's going to happen in the simulation, or if you just want to dictate what they need to do, you just record. As soon as you stop the recording, it saves it as an MP4 format, which can be played back on any type of system. So you can use that for online teaching or just to give them an overview before they're actually going to have to build the schematic. Okay, so we can go, and I mean, we can build all kinds of schematic. Like, for example, I had an instructor last time, he says, I don't like that I don't see the pressure from the relief not going back to the tank. It looks like it's three different tank here. So I said, no problem. What you can do, because if you expand hydraulic here, there's many more components in each subcategories. If I go, for example, here, actuators, we have single acting, double acting, telescopic. So if we go in reservoir, you can take a multi-port reservoir like that. And I'm going to say I want to have, let's say, 12 port on this. So now you see I can erase this port, erase this one, and actually come here and connect this one like that. Okay, so you see I'm a bit off, but let's just move it a bit like that and it stays connected. And this one, I'm going to erase it, and I'm going to use one that doesn't have a reservoir attached to it, like this one here. I'm going to have to flip it, so I can go to the Edit tab, Position, and just flip it like this, connect it over here, and this bring it back to the tank like that. If we simulate, it's the same thing. Okay, if your circuit is well done, it's going to simulate like in real life, but this, for some, it's more visual to actually see everything going back to the tank at the bottom. Okay, so this is the quick overview that I wanted to show for the hydraulic. There's much more features that we can do. We can use dynamic measuring instrument to take measurements directly on the schematic of pressure, flow, temperature, viscosity of the oil, differential pressure. We can change the oil type to analyze different type of fluid, if it's thicker, thin, lighter. But this could be done on a personal presentation. So after the demonstration today, you can contact us and we can definitely schedule a more in-depth presentation with you and your colleagues, more oriented towards your program. Okay. So now, if we stick with the hydraulic, you see there's a lot of components, and it could be a bit overwhelming for students to try to look for what they need. Okay. So a very good feature of Automation Studio is the capability of creating your own library. That's very important. So for example, if I click on this book here, it's asking me to save it. So let's save it to, let's say, FAMIX library. For example, if I was a school, I could call it the name of my school or even your own name, it doesn't matter. So now you see I have a FAMIX library that's empty. Right now we're working on hydraulic, so let's create a category here called hydraulic. And let's say this is your lab 1. I can create a subcategory called lab 1. And I can expand a bit the bottom part just to make it more visible. And I can simply drag and drop these components like that back in the library. So students don't need to look for the components. They can just go here, take whatever symbol they can see, build their schematic from what they have in this library. That saves a lot of time. And at the beginning, your goal is not really to try to confuse the students not taking the right symbol, but you want them to start building schematic. Down the road, you may want to put more components to just confuse them, but that's up to you. And for example, what you can do, you see this one, we've changed the properties of it. We've put an angle, we've put a text over it. If I drag it in the library, it remains like that. I can rename it, let's say with 5,000 pound. And if I take it out, you see it keeps all its properties as well. So if you have created faulty component and you put them in your library, students will not know. It will just use it, drag it on the schematic, and then when you simulate, something wrong is going to happen. Well, then he needs to figure it out. For example, this could be your power unit. Okay, let's say you say, oh, I want to have a filter or something. I can place a filter here if I want. You want to have a check valve, whatever you want, okay? And I can select all this. I can group it. And I can go in my library here and put all this here. And I can simply rename that power unit, for example. So maybe in lab 1 or 2, you want them to do all these parts separately, but when you reach lab 3 or 4, you may want to give them focus other places on your schematic, so this could be already made for them, okay? Building the custom library like that, it's really interesting because you can also put pictures beside the component. And this is also very interesting. If I open a library that I've created, hold on just here, you'll see that what I've done in the picture area, put pictures like that beside the symbol. So these pictures can be pictures of your own equipment or actual picture that you took from the web, for example. Okay, so this is pretty simple to do as well. Okay, if for example you want to take a cylinder like this here, and I want to add a picture over it, I can go here on Google, for example. I can search for hydraulic cylinder. There it is. Okay, I can go image. Let's say that I really like this image. I want that to be over my component. I can right click on it, copy image, go in Automation Studio, just paste it, shrink it to the size that you want. I can select both components like this, group them as one, go in my own library, and simply drag it in here. And I can rename it. So JPEGs or PNG of your own equipment, you can just cut and paste into your custom library like that. Okay, so this is really interesting because you see, like here, I've created a library of my own. But if, for example, I have like a Parker hydraulic trainer, I could have created a section called the Parker trainer and have the same pictures with the components like that. So the students, when they use it, they know exactly how it looks like. So when they go move on to the equipment, it's going to be much easier for them. They will be more efficient because they'll know, okay, this is the pressure relief, this is that. Okay, so it's a good part of the learning. And working with the symbol like that really does improve the blueprint reading skills also. Okay, so now I've showed you pretty much what I wanted to show you here. Another important thing about the hydraulic and pneumatic is we have manufacturers' catalogs. Okay, this is something important. We actually have these catalogs accessible on our website. Okay, so if you go back here, for example, and you go on Femic Technologies website, product manufacturers catalogs, we have catalogs from these manufacturers. So for example, if you want to use a specialized component from Eaton, you can click on Eaton and then you can have access to the component from Eaton with the exact part number that will behave exactly like in real life. This was more asked from our industrial department, but because you're a school and we give access to everything, you will have access to this catalog also in Automation Studio. Okay. So now we've done this, I want to show you something that we have created because of the COVID situation. A lot of schools contacted us and mentioning that they've lost access to their trainers because they had to do more online teaching. So we've created a library with illustrated component. Okay, so this one that I'm showing you now, it's work in progress. It will be released very shortly, okay, but just to show you. So hydraulic illustrated component. If I open this library, here I have some elements that I can actually drag out on my drawing here and connect. So if I take, let's say, like a pump like this, then I'm going to use, let me just zoom on a bit because it needs a bit more space with the images. Let's say I'm going to put a reservoir. So I can connect this to the reservoir. Then what I want to use, I'm going to use, let's say, a pressure valve, pressure relief. Let's say like this. I'm going to take a directional valve, a 4-3-directional valve, let's say, with a lever like this. And then I'm going to put a double acting cylinder. So you see it's, oh, this is a single, sorry. So you see it actually feels like you're connecting real elements. So when you go on your trainer, this is exactly what you would do basically. Okay, so let's say I'm going to come here. The pressure will come from here. Then and this is going to go back to the tank. And my pressure relief will connect here in the middle and go back to the tank as well. So now when I simulate, oh, sorry about that. Oh, I know that because all done. It's just a matter of simulation paste. Okay, so sorry about this. Document project properties here. Our simulation pace is a bit too quick. So hold on. Hold on, it's here in the simulation. So I just need to go to about 2 milliseconds. Because with our electrical module, we've added more precise simulation. So we have a better response. But for some of the module, you just need to go back and I use a more regular simulation pace. So you see here, let me just zoom window like this. So we see we're actually now controlling like I would on a real trainer. Okay, it's not fast enough. I should have increased the flow, but anyway, just give you an idea of what you can do with this wheel looking, and then you see the relief is actually sending back the oil to the tank. So this is what we've done, and it allows you to actually make schematic like that, and you still have access also to being able to modify the properties on these components. See, for example, if I open the behavior here, I can click on my cylinder and actually change the length of it, the diameter. So I still have access to the technical properties, even if we're using a visual aspect like that. Okay, so this is for the illustrated hydraulic library. So this will be released like very shortly. Okay, you will receive it with the version 7.1, but it's important for you to know that these are always work in progress, and we really count on our customers' feedback to actually add whatever component may be missing for them. Because to tell you frankly, we've created these more for the educational purpose. And in education, we don't use all the components from the libraries, and that's why we try to put the ones that are more commonly used: sequence valve, pressure relief valve, flow meter with check, without check, things like that, single acting cylinders and things like this. So we create some, but if you do feel that some are missing for your purpose, you just let us know and we'll create them for you. Okay. Our goal is to have these library that contains all the necessary components for you to make your program. Okay. So now I'm going to open another document, okay? And on this document, what we have created is cross-section views, okay? So you see we have in the template here, it's called fluid cross-section view. If you open this diagram, the reason why we created a model, a template for these, it's just because we've put the line thick by default. So you see here, we actually have a bit the same thing. You see, if I click on this library here, the first orange icon, I can open some illustrated libraries: DC electrical, renewable energy, residential electricity, cylinders with loads, you know. So here we have the hydraulic sectional component library. Okay, if I open this, you see we have here all these components that you see on the right comes from these library. Okay, so if I do the simulation, you see we actually now see the inside of the components. Okay, so if I click on the lever here, I can actually control the valve and see what's happening in the system. And again, this is all built like you want. So if I take this and I just hit the Control key and I copy it, I can do the exact same thing we did before. I can connect this in parallel with the other one like this. And now if I simulate, that's the beauty of Automation Studio. You can do any circuits that you want with using these components. And it's very easy and quick to do. Okay. So this is for a bit for the hydraulic part. So now we'll jump into the pneumatic. We'll go a bit quicker than pneumatic because we don't need to, it's basically the same thing, but we will use the pneumatic and we'll use the electrical control to create an electro-pneumatic circuit that you could have done the same thing with hydraulic also. Okay, so let's just do a new project here. And I'm just gonna take a standard imperial. And now I'm going to go into my generic component, pneumatic this time. And let's do the same thing. So let's take a double acting cylinder. Let's just use a 5.2 with a solenoid. Connect this together. I'm going to use a pressure source and 2 exhausts. By the way, in Automation Studio, if you've been a user for a long time, we always need to put an exhaust. because by default, when you launch the simulation, all the open ports get blocked. Okay, so but we can change this. If you want, you can change the properties in the software. So when you have an open port, it's like an open port. So the air leaks out. Okay, so if you want it to be more realistic, for your students, let's say if they have a hose that the hole that is open somewhere, maybe the circuit will not behave correctly because the air is going out. You can do that. Okay. Now, if you see the question mark here, because it needs to be connected to an electrical circuit. If I simulate now, I can just test my circuit by clicking on the actual override here. So, okay, the circuit works well. I mean, it's not very complicated, but you understand what I mean. It's just to show you the principle. And now beside this circuit, this is what we could have done with the hydraulic as well. I can actually do a very quick relay logic circuit. So if I put like a push button over here, let's name this push button start. You can use any type of name that you want, okay? It doesn't matter. Let me just zoom in a bit so we see a bit bigger like this. I'm going to put a coil here, a relay, and let's call this control relay 1. I can make the connections between the components. You see the software automatically knows I'm connecting electrical. If I try to go like this, you see the line is red. It tells me this is not possible, okay? So then I'm going to use a normally open contact. As soon as I will drop it on my schematic, the software is going to ask me to which relay do I belong. So this is a contact of CR1. So I'm going to filter here for C, and you see CR1 is here. You double click on it, and the question mark on the left will change to CR1. And on the drawing, now they have the exact same name. Now I'm going to put a solenoid over here. I'm going to call this A+. So I can just connect this like that. And now I need to associate this to my solenoid over here, A+. Click twice on it. Filter for A. And you see A+ is over here. Click twice. And as simple as that, I have now created a electro-pneumatic circuit. But you see every time I let go the mouse button, the springs push the valve back. So if you want the students to push only once and it goes all the way to the end, it's for them to know that they have to put a wire here to keep CR1 energized. But at one point, you want it to retract. So I'm going to take here a normally closed push button. I can drag it directly on the schematic. It will automatically cut the circuit and insert in here. And let's say call this return. So now if I start simulation again, I hit start. It stays active because you see it's still closed. If I open the circuit, it retracts. You may not like the way I did the circuit. I had a teacher telling me this once, says, no, this is not how we draw this. So what he wanted to do, basically, he wanted to do it this way. Okay, let me just do this a bit fast here. I can hit the control key to copy CR1 here. You see it's a bit off, but they stay connected, so it's easy to realign. Go like this, and he said that he wants the return to be here instead. If the circuit is good, it's still gonna work. So if you want to show your students to isolate the button just like that, just with a contact, and so it's easier for them to understand, be my guest. The logic is good, it's gonna work, no problem. Okay, so this is how we create the electro-pneumatic circuit. Okay, now with the pneumatic, we have the exact thing as we did for the hydraulic. So we have an illustrated pneumatic library. So if I take here, for example, I click on this book, open library again, and I'm going to open now the pneumatic illustrated library. If I do okay, you see I have a bunch of libraries. I can just click on them and close them, okay? I can choose whatever I want and just close them like that so I see less. Okay, it's up to you. So I don't need any more the hydraulic illustrated. Let's go with the pneumatic one. So Right here, all I can do is actually drag and drop the same thing. I have an FRL here, for example. Let's put the pressure source. So that's connecting to my wall. There's you go. Then for that, I'm going to take a directional valve, a 3-2, let's say, and a solenoid valve. Okay. So I can combine the two technologies also together. So you see the solenoid valve here like that, and a spring return cylinder, actuator, spring return, with no sensors or nothing on it. So I'm just going to take this like that. I connect this here, connect this over here. I need an exhaust for the cylinder. So I go into my flow and line, exhaust. I can put an exhaust here like that. So now, let's say if I erase this, now I want to link A plus to this valve. Simple, click on this valve, filter A plus, click twice, and the link is made. If I simulate, you see, I have the exact same thing that we just did, but now I'm combining a bit of electricity with the real looking type of components. Okay, so we can still, so whether you use, I should have put it here so it, when we zoom all, we see it a bit bigger, but we can combine the illustrated images with the symbols if we want. Okay, and you see again, if I click here, you'll see the light on the solenoid gets activated to show it's on, and then return, it retracts. If I take here, for example, I remove this, and I take an adjustable exhaust, and I simulate, and this, I almost close it, and I do the same thing, the pressure builds up, return, let me just close it a bit more. So now it's retracting, but you see it's not letting the air go out. So if I go like this and I open it more, you know, I actually control the output of the air. Okay, so again, whatever schematic you make, you'll be able to illustrate what's going on in the system. Something also that's coming new with the version 7.1 is going to be the cutaway animation for pneumatic also. Okay, so this is something new. So let me just erase all this because we've done it now. So let's just delete that. Same thing, if I go to fluid conditioning, I can use an FRL like this. So this will show the inside of the component. Okay, the compressor. Okay, I don't really like the compressor, but I mean, this is a model they took. But anyway, it's again, keep in mind that what I said at the beginning. If you have components that you would like to see in Cutaway because you feel it's missing for your program, please let us know and we will create those. Okay, so I can connect this here. Then let's just take a directional valve. Let's take a 3-2, just make it simple. And I'm going to take a spring return, extend cylinder like this. So I can just make my connections like we did before. I can just align that like this, and then I'm going to take an exhaust. Okay, so it's going to be into flow and lines, exhaust. This, you see, it's in work in progress. The order is not even like how it should be, okay? So it's going to be all adjust. I can go like this. And now if I simulate, okay, so now I can actually activate the valve to launch a simulation. Okay, so you see, so this is how very easily we can actually work out and do the simulation of the circuit directly into Automation Studio. Okay, so again, if you have any special needs, you let us know and we will add whatever component you feel that's missing in the software. Okay. So this is a bit about the pneumatic component, the cutaway I want to show you. So for now, for pneumatic and hydraulic, we have, for both of those technologies, we have the capability of doing illustrated view, symbolic view, and cross-section view for pneumatic and hydraulic, okay? So now we can cover pretty much every aspect. I had a customer yesterday, he says, I have no hardware equipment for hydraulic because he can't afford it, it's too messy, and then when he saw the software with the hydraulic illustrated, he said that's exactly what he wanted, because at least now he can show them how to wire up, let's say, an hydraulic circuit, as well as seeing the symbol circuit right beside it simulate together. You see, for example, if I open here a circuit, we have both scenarios. So you see here illustrated pneumatic. I've done this one here. It's like a timer, and so you'll see a symbolic view of a circuit, and right beside the illustrated view, something like this. So you see here, it's like I push the cylinder, it extends. After 3 seconds, it will extend the spring return one. And when I release, they come back. I can do the exact same thing here now. If I energize my circuit, I can turn on my gauge, which either shows PSI, bar, or Pascal, megapascal. And then when I zoom out, if I push this button, cylinder extend, timer set for 3 seconds, then extend the spring return. So this is the quick introduction to hydraulic and pneumatic. Like I said, keep in mind that we can schedule an online presentation with you and your colleagues to go more in depth in each of these technologies. And then now what we're going to do, if we go back to the presentation at the beginning, now we're going to build the first part of our multi-technology project, which is the pneumatic section over here. Okay, so after we've done this, I will be open for questions. So if you do have some, please, it won't be long, 10 minutes, and when we should go for the questions. So let's erase all this and let's do a new project. Standard template. Let's open the library. Well, as we saw in the PowerPoint, what we need now is the pneumatic illustrated library. So as you can see on this picture, this source of pressure is not just an input source. It's actually a compressor that will receive the signal from the electrical motor on the other circuit. So you see here, there's a shaft connected motor that goes to this one. So it's a bit different. So we're going to just go here. We'll take the compressor, and we'll take the compressor with shaft like this. Because now you see this will need to be connected to be able to be driven, okay? So now after that, we need an FRL. I can connect my circuits like this. And by the way, you see all our lines are like squares like this, and we are currently developing some flexible wires. So you will have like a kind of real feeling of a hose that's connected instead of having those straight lines like that. It could become very handy when you have a bigger project, because sometimes lines are hard to follow all over the place, but this will be like really connecting a hose. Okay, so this is something in the pipeline. We received maybe like a couple 4 or 5 months before it's released, but this will bring this to another level. So it's going to be very interesting as well. Now this is an FRL. Sometimes on an FRL there is a shut-off valve. So here I'm going to put a shut-off valve, which will be this is a normally closed one. Perfect, normally closed here like that. And this will supply air to a manifold. So here we're going to take a manifold. like this. But as you can see, there's multiple holes on that. So we need to block the holes that we will not need. Okay. Well, I'll do that after. I'll do that after because I'm not sure how many ports I'm going to be using. So this is done now. So I need a 5-2, a 5-2 with 2 solenoids because it's going to be an electro-pneumatic circuit. I can place that here. And I'm going to take also a double acting cylinder, but this time I need with 2 proximity sensors. So when I drag it out like that, you see that I have 2 prox sensors on the cylinder, PS1, PS2, because I could have taken, you see like here, we have some with mechanical contacts. We have some with sometimes 3 mechanical contacts, and we even have one here that was created. You see, a customer of us asked for this type. So 2 little sensors like this on one side, and then one like that in the middle on the other side. So you see, if you don't ask us for specialties like that, we won't, we don't know. So if you do send us an email, we can create them for you. So now that I have made my components on my drawing, I just need to connect this together. So I'm going to connect this port here, this one over here. This one, it's the port 1, so I need to pressurize this port. And I'm going to need 2 exhaust here. So I'm going to go to exhaust, 1 over here. I can hit the control key and just copy it here. But I need to close these ports now. So I'm going to go into my manifold here, and you see the plugs. So I can put a plug here, plug there. Yeah, I'm hitting the control key every time, okay? So I just duplicate that. And this one here, I need to rotate it. So I'm just going to go to the Edit tab and rotate 90-degree to the right. I could have just right-click on it also if you want to, and go here and do transformation, and then do rotate right like this. Then I position the cursor. So now my circuit is done. As you see, as it is on my illustrated pneumatic. Oh, I'm missing a pressure gauge. You see here, I have a pressure gauge. Sorry about that. So let's remove the plug. Go to measuring instrument, a pressure gauge, and I'm going to connect the pressure gauge over here. We have fitting also because when you have a three line connected together, you need to use a fitting like that. Okay, so we've done those. In my case, I don't need any. I'm pretty lucky, but if I did, I would use this because, as you know, in Automation Studio, I can come and directly connect like this, but in real life, you can't really do that. So in this case, the students would have to take this like that, a fitting, and actually just bring it like this and connect it in the drawing, okay? So we have the fitting as well. That's all I just wanted to show it to you. So now if I want to test this circuit, if it's gonna work, I can actually start simulation. You see my Prox1 is activated, but there's no air in the system because like I told you before, this needs to be driven by a motor. So until we have the electrical part done, what I'm going to do, I'm going to come in my generic library and I'm going to take here in drive-in transmission, I'm going to take the motor that we used before. I'm going to rotate it like this and connect it to my compressor. So now if I simulate again, you see now my compressor is spinning. I'm pushing air to my FRL, but this shut-off valve is closed. If I open it, now I can see my system is pressurized. And then I cannot activate the valve now because I have no electrical circuit. But if I open the variable management, if I go tools, variable manager, and here if I remove this filter, you see I have sol 1, sol 2. So if I click here, I'm going to force sol 1. So you see it's extending. And so sol 2, it's retracting. So I can test my system like that because I can force my variable directly on the cylinder. So I know my circuit is well done. So now all I need to do is actually save this up. And next week, we're going to build the electrical part, and then we'll be able to actually bring in here the feedback we receive from the electrical motor instead of having a directly connected motor like that to the compressor. So this is what I wanted to show you today. So we have created this part. And again, next week, we'll do this part here done. So thank you very much for being here today. If you have questions, this is the time. So if you want, if you have a question, I can give you the mic. You can raise your hand on your GoToMeeting interface, or if you prefer to write it down in the question section, I will be more than happy to answer, give you answer to your question live today. So in the meantime, thank you very much for those who have participated today. We will send you a link to the recorded webinar that we did today. So if you want to review it or share it with colleagues, feel free to do so. So thanks again, and we'll see you next week, hopefully. Thank you.